Hi everyone, I am Suresh Bathini. I work at Sony Interactive Entertainment, which is a maker of PlayStation. I started at PlayStation in 2012. When I joined 2012, I was hired to work with a team of people to modernize the PlayStation network. We were in charge of bringing in new web and cloud technologies. That was our goal in 2012. We accomplished that. And in 2013, my team and I led the group to launch PlayStation 4. As you know, PlayStation 4 is quite popular. It's very good. It has done really well. And since the launch, it has grown significantly, and the scale and the number of customers and the engagement kept growing rapidly. As the demand for the users and the console kept going up, we had to invest a lot of time in making the services that were powering the PlayStation ecosystem more resilient and available. So we invested a lot in going to multiple regions within AWS cloud. That was something that we accomplished in 2016. And since 2016, we've been heavily focused on becoming a data-driven company. And 2018 is when we unlocked the value of data within the company. And since we have a lot of data, we leverage the data to start investing in personalization, machine learning, and those are the efforts that we are working on right now, and we have delivered some of them, and we're continuing to invest in machine learning. So just to give you a snapshot of what PlayStation is about, PlayStation Network has a lot of immersive gaming experiences. We have lots of games, 500 plus games that are available on PlayStation ecosystem. You can play in single mode, you can play in multi-mode. On the storefront, you can browse, search, look at, you can look at your personalized recommendations and purchase games. We also have video capabilities where you can rent a video or buy a video. You can also engage socially. You can find friends. You can engage in parties. You can do a lot of other community activities also on the ecosystem. And just to give you a high-level view of where is PlayStation today, we have 103 million active users. We have about 38.8 million PS Plus subscribers. And by the way, we are one of the top subscription businesses in the world. And we have generated revenue of about $21 billion in the last fiscal year. We also sold 5 million VR headsets. Speaking of personalization, the personalization journey involved three big stages. One was obviously getting all the data that we have in a place that we could use it. The second is about what do we do with the data and how do we make sense of the data to understand our players. And then the third is what did we do on the personalization. So I'm going to talk about each of these areas in this presentation. So before I talk about personalization, I wanted to give you a sense about the scale we are dealing with, right? We have hundreds of microservices delivering millions of requests per second. We collect 100 plus billion events per day. And then we have many database clusters and we are on multiple regions. So anything we do with personalization, it has to support the scale that we have. And you cannot leverage edge caching like Akamai or CloudFront to solve these personalization problems because everything has to be specific to a user. So we have to think of the technologies that would help us with personalization. Right. From a data perspective, the challenges that we had, when we started this data initiative in 2016 were like, we were collecting a lot of data. Every team that was involved in delivering some level of experiences or services had data. The challenge that we had was they were all multiple data islands. Data was in different formats. There was no single dictionary that would tell you what all data PlayStation had. And then also we were using data, in marketing and some aspects of end user personalization. But I feel like there was a lot of immaturity in terms of how we leverage data. So these were our challenges. So when we looked at all that stuff, so we, instead of building a centralized data platform, we came up with a concept called Data Ocean. And the principles behind Data Ocean are really to federate the data ownership, not to have a single owner of all data. So the team that creates or sources the data would own the data and store it as data lakes within their respective cloud accounts. The only central thing that we required was the catalog. We called it the dictionary or the catalog, which kind of had information about where all the data is. And we use two types of catalogs. We're using AWS Lake Formation for the lakes catalog, and we also have Alation, which helps scientists understand what all data sets we have, because you can augment data on top of what you have in the core catalog. And this is what we built. And with this, what we could do is, teams could come in and look at the data and enrich the data and create more data sets which were available for machine learning engineers to use these to personalize and deliver personalized experiences. And we could also use the same data sets for enterprise reporting to drive business results. So from a personalization perspective, we wanted to build aggregated, curated data sets, which really talked about what the players are and had segmented users, segmented users by genre, by spending patterns and various aspects, right? So we had a lot of machine learning opportunities at the data level itself, where we did a lot of offline investments to curate the data to create audience segments by various dimensions. And we also invested a lot in feature engineering to generate attributes for each user. So that way, if you wanted to do a personalization campaign for people who spend at least $50 a month, we had all those, capabilities attributes that were generated for each users. And that's where we spent a lot of time on machine learning, both in the offline and then at runtime. I'll talk about it a little later. And then to enable this personalization, we invested in building a lightweight machine learning platform. Think of this platform as a system that allowed machine learning engineers to create their models, deploy their models, run their models, manage workflows for their models, to really help with training. And once there was adequate training and adequate confidence in the attribute and the features that they generated, we would push them to the prediction layer. And you can see the purple box is the runtime store, and that's the topic of today's talk that I'm talking about. So I'll get to that in a second. So when it comes to feature store requirements, we had some requirements in place, right? We wanted a backend database store which can handle 100+ millions of users, right? And we were looking for a store that can handle several terabytes of data. And we were generating attributes and features, 100+ features per user. So we wanted a store that could handle that scale. And our data retrieval, we had to make snap decisions at runtime at a scale of millions of requests per second, and our latency requirements were to be under 10 milliseconds. And we also wanted our total personalization solution to have low cost, total cost of ownership to be reasonable, right? And then we were looking at various database systems, and one of the things that is, if you look at early days in traditional relational databases world, where you would vertically do your scaling by throwing in bigger and bigger hardware at the problem. But with internet scale, the data volumes have grown exponentially, and that's when distributed systems became popular. And when it comes to distributed systems, one of the things that is quite popular with distributed systems is the CAP theorem, where and the CAP theorem, what it says is, you have this consistency, availability, and partitioning, but when it comes to distributed systems, you can't have all three. You can only have 2 out of the 3. So if you look at it, relational systems are very good with consistency and availability, whereas if you look at systems like HBase or MongoDB or Redis, they're good with consistency and partitioning. And if you look at availability and partitioning, the NoSQL systems come into play, right? That doesn't mean the NoSQL systems like Cassandra, Aerospike, and Couchbase are not consistent. They're eventually consistent. So for us, we felt scale is important, consistency is desired, but eventual consistency is fine, right? So we chose, we decided that availability and partitioning is what we're looking for, and the candidates were Aerospike, Cassandra, and Couchbase, right? And how did we decide which one made sense for our personalization? So we looked at various aspects of these database systems. And don't get me wrong, all of these are great database systems, right? And we use Couchbase for some use cases, we use Cassandra for some use cases. So given the personalization scale and the low latency requirements that we had, we felt Aerospike's design of designing their design is based on flash optimized in-memory database technology, and which is what we felt like it is a really good thing for the use cases that we have. We also felt from our experience, the sharding, all of them have automatic sharding, but I feel Aerospike sharding has been operationally the less painful. It's almost self-healing. And from operational overhead as well, we haven't had that many issues with managing the system. Total cost of ownership is pretty low because the small cluster could handle several terabytes of data. And based on all these things, we felt like for our personalization use case, we chose Aerospike. Right? And then from a personalization perspective, we have a lot of opportunities within PlayStation ecosystem when it comes to personalization. I mean, obviously recommending games to players, games because they bought something is one avenue. We also do friend recommendations. We match people on multiplayer game capabilities where we find people with similar skills and match them based on various attributes and models that we have. And we also use machine learning for fraud detection. So we have a lot of use cases. Our eventual goal is to make all experiences and all games that users engage with much more personalized and much more user-centric. Right? With that, I thank you for listening to my talk. And by the way, we are hiring great engineers. So if you're looking for an opportunity, hit me up on LinkedIn and we can go from there. Thank you.